Myself, Sanjay Udge, Assistant Professor, Department of Electronics Engineering, Walchand Institute of Technology. Today we are going to discuss DC circuits, calculations of circuit parameters. Learning outcomes. At the end of this session, students will be able to apply the various simplification methods to analyze DC circuit. Guideline. Various techniques to solve numerical based on DC circuits. Identify given parameters of a network. Assign names to different nodes and start solving from a particular branch. Questions, references. Various techniques to simplify DC circuits. In the previous session, we discussed Ohm's law, KCL, and KVL. These laws are used to simplify the given complicated network. Various techniques to simplify DC circuits. Identify given parameters of a network. What is Ohm's law? V is equals to I into R. In this case, we are having three parameters: voltage, current, and resistance. Here, two parameters are known. Then we can find out third parameter. That is, if in a branch voltage is given and resistance is given, we can find out the value of the current. Here, this is a circuit, voltage source with resistances R1, R2, R3, R4. Okay. Here, if it is required to find out current I2, I must find out the current I1. Okay. Next, to find out current I1, I must know the equivalent resistance of the network. Here, it will be R1 plus R3 parallel R2 plus R4. So if we find out the equivalent resistance, then only we can find out a total current I1. After finding I1, we can find out I2 and I3 from a current division rule. Let us consider one circuit to find out our electrical parameter. I will draw the circuit here. This is circuit having four resistances. Supply voltage is 12 volts. This is the resistance having value 500 ohm. This one 50 ohm. This one 550 ohm. And it is required to find out value of resistance R. Now, first let us give the names to various junctions. Say A, B, C, D, E, and F. As I told you, if to find out the value of resistance between B, it is necessary to find out voltage between B, that is voltage across resistance R, and as well as current flowing through branch B. Then only we can find out value of resistance R. Now, as it was discussed earlier, start solving the network from that branch where more information is given. Here, one more information is given, that the drop across this 500 ohm resistance is 2.5 volt. So, in branch CD, we are knowing two parameters, voltage and the resistance. So, we can find out value of the current, that is ICD, that will be equals 2.5 volts divided by 500 ohm resistance, and it comes out to be 0.005 ampere. Next, according to the property of series circuit, 500 ohm resistance and 50 ohm resistance, they are in series. It means that this current same current is flowing through this 50 ohm resistance. So I can find out value of voltage drop across 50 ohm resistance. That will be equals to 0.005 multiplied by 50 ohm, comes out to be 0.025 volts. Now, as I told you, these two resistances, 50 ohm and 500 ohm resistance, they are in series. So drop across 50 ohm and drop across 500 ohm resistance, they will get added. So I can say VBCD, it will be equals to 0.25 volts plus 2.5 volts, and total it will be 2.75 volts. Now, if you look at this network BCDE, branch B is coming in parallel with the branch BCD. It means that according to the property of parallel circuits, VBE must be equals to VBCD. Now I can write VBE must be equals to 2.70 volt, which is the voltage across VBCD. Next, so I got here 2.75 volts. Next, here I got VBE as 2.75 volts. Now the remaining part is find out IB. This IB, then we can find out RBE. How to go for IBE? Now let us go to the branch AB. This branch AB, let us find out the voltage across VAB. The total voltage, supply voltage is, V supply voltage is the 12 volts. The voltage drop across VB is 2.75 volts. So VAB will be equals to VS minus VBE. So VBE will be equals to 12 volt minus 2.75, comes out to be 9.25 volts. So I can write here 9.25 volts across VAB. Next, if you look at this branch AB, we are knowing voltage AB as well as current RAB. It means that we can find out value of IAB. IAB will be equals to VAB upon RAB. VAB is 9.25 volts, RAB is 550 ohm. So IAB comes out to be 0.0168 amperes. Now let us apply KCL at the node B. Let us apply KCL at node B. Here current IAB must be equals to IBC plus IBE. That means IAB is how much? It is 0.0168. IBC is 0.005 ampere, and the unknown current is IBE. With this, I can find out value of IBE, and it comes out to be 0.0118 amperes. So this is finally I got value of IBE. Now coming back to the branch BE, here we are knowing two parameters. One is IBE and VBE. Now I can find out the RBE. Value of RBE, I will write it as a VBE upon IBE, and it comes out to be VBE is how much? It is 2.75, whereas IBE is 0.0118 amperes. Finally, RBE comes out to be 233 ohm. So this is how we were able to find out the value of unknown resistance. To find out the unknown resistance, as a summary, to find out the unknown resistance, we must know the drop across this, as well as we must know the current flowing through this unknown resistance. Okay, so That's why we started from that branch, that is CD branch, where uh, more information is given, 2.5 volts as well as 500 ohm. Then we found the current ICD, then voltage across BC, that is 50 ohm, the total voltage appearing across unknown resistance 2.75, because BCD is coming in parallel with BE. Okay, then we got the value of voltage across this. Okay, then current flowing through this AB, and using KCL, current flowing through this IB. Now one more simple example I want to take is, see, this is one more circuit, two resistances in parallel. So this is R1, R2 and R3. So this, with the help of this current division rule, we can find out I2. Okay, now if it is required to find out I1, you must know IT. Now to find out IT, you must know R equivalent. So first of all, find out R equivalent. It will be R1 plus R2 parallel R3. Okay, then find out IT. Okay, that will be equals to total supply voltage upon R equivalent, and then using current division rule, you can find out I1 as I total into R3 upon R2 plus R3. So this was the discussion, the acknowledgement, reference books, Electrical Technology by B.L. Theraja. Thank you.